A rubber ring had one job and one instant to do it. At ignition, a gap opens inside the rocket for a few thousandths of a second. The ring must spring into it and seal it before the fire gets out. That morning, the ring was too cold to spring. First, the record. 7 people were aboard. We named them once, quietly, because every drawing in this catalog begins with what it cost. Dick Scobie, Michael Smith, Ronald McNair, Ellison Onizuka, Judith Resnick, Gregory Jarvis, Krista McAuliffe. Now the machine, working. The solid rocket booster is too tall to ship in one piece, so it is built in segments and stacked at the cape. Where 2 segments meet, they form a field joint. For 24 flights, those joints held. Look closely at one joint. The upper segment ends in a tongue called the tang. It slides down into a U-shaped channel on the lower segment called the clevis. 2 rubber rings sit in the gap, a primary seal and a secondary behind it. Putty packs in front to face the fire. If you would rather understand why things break than watch them break, subscribe. A new drawing is filed here every week. Hold the joint in mind. Its whole life is one instant. Here is the flaw, exactly where the record left it. Rubber springs back, unless it is cold. Cold rubber goes stiff. The maker had no test data below 53 degrees. That morning, the joint sat near 28, 15 degrees colder than any launch before it. The night before, the engineers saw it. They recommended against launching in the cold. Under pressure, the recommendation was reversed, and the launch rationale was signed. The line was visible on paper. The decision crossed it. Watch the amber. At ignition, the booster pressurizes and its wall bulges. The tang and clevis rotate apart, and the gap the ring must seal opens wider, at the worst possible instant. Now 2 things race each other. The race is the gap opening against the seal closing. A warm ring springs into the gap and wins. The cold ring is stiff, it lags. The gap is essentially open within 0.6 of a second, and the seal never seats. Here is the line the engineers could not stop. You are about to see it. Hot gas finds the open gap, blows past the primary ring, past the secondary, and out through the joint to the open air. At first, the breach sealed itself with slag. Then the seal reopened, and the leak became a torch aimed at the tank. The booster pulled from the tank, and the vehicle came apart at about 73 seconds. We hold here. The drawing is enough. The Presidential Commission was plain. A gas leak through the right booster's aft field joint at or shortly after ignition breached the tank and broke up the vehicle. The cold had robbed the seal of the one thing it needed. So had the decision to fly. One commissioner made it unforgettable. Richard Feynman clamped a piece of the same rubber, dropped it in a glass of ice water, and showed it would not spring back. The whole failure in a glass of ice water. And here is why yours holds. The joint was redesigned, a capture feature that locks the tang-and-clevis and removes most of the rotation, a third rubber ring, and heaters to keep the seals warm. And a harder rule: when the engineers say stand down, you stand down. Failure mode, seal failure, a cold, degraded O-ring in a rocket field joint. Nothing breaks without a reason. Now you know this one. Drawing filed.